In this movie, we're going to talk about collisions in Unity. Unity has a very nice physics package built in that lets us simulate real-life collisions, both in 3 dimensions and in 2 dimensions. In this game, I have created 2 game objects, a sphere and a plane. Now, if we want those game objects to respond to the physics of Unity, we need to add what's called a rigid body component to them. But before I do that, I'm going to go ahead and play my game, and let's see what happens in my game. Well, nothing is happening in my game because Unity doesn't see those game objects as really being objects that can respond to physics. If I want an object in Unity to respond to physics, like I said, I add a rigid body. How do I do that? I select the item, I go to the inspector, I go to the bottom where it says Add Component, I click on Physics, and I can add a rigid body. That's not the only way to add a rigid body. I could select the game object in the hierarchy, go to Component, Physics, and there's rigid body there. So again, Unity gives you a variety of ways to add things and to manipulate things. So now I have this rigid body component over here. There's several things here to look at. One is the mass, the drag, angular drag. Those are all things that are important when this game object is interacting with other objects. Another thing we need to look at is collision detection. We can have discrete or continuous. We're going to use discrete. Continuous really can compromise your game performance. Sometimes you need it, most of the times you don't. Another thing you need to look at is called constraints. You can freeze an axis of position or rotation for a game object when it interacts with other game objects or interacts with the physics of Unity. For example, if I don't want the physics to affect the x-axis, I just click the x-axis under freeze position. And maybe I don't want it to rotate according to the y-axis, then I click that. And that's useful in many games. We're not going to use that right now, but later on we might. Okay, another thing you might notice is whether or not we want to use gravity. Well, we can definitely use the physics without using gravity, but in this case we are going to use gravity, and you're going to see why. So I'm going to go ahead and play my game, and let's see what happens. Gravity affects the ball, and the ball drops. All right, pretty cool. Now let's talk a little bit about the plane. The plane does not have a rigid body on it. All right, so the physics of the world do not apply to it. If they did, the plane itself would also be pulled down by gravity, and both the ball and the plane would drop out of sight. But we want the plane to stay there. Now, that brings us to another concept. That concept is a collider. A collider is simply a perimeter that's projected around a game object that can detect when other game objects run into that game object. In other words, it's a boundary that's used for collision detection. Every game object comes with a collider built in. If you look over here, we have a mesh collider for the plane, and we have what's called the sphere collider for the sphere. So those are built in. If we want a special collider, we can add it to a game object, but these are pretty good right now. Again, if you wanted to add a collider, you'd go over to the inspector, you'd go physics, and then you could choose a collider. But we already have a sphere collider, so we're in good shape. Now, the plane itself, like I said, does not respond to the physics of the world because it does not have a rigid body. Any game object that does not have a rigid body is referred to as having a static collider. And that's really important to remember. Static colliders are things that don't respond to the physics of the world, but still can detect a collision. You might want to use static colliders for things like floors or walls or things like that that you really don't want to respond to gravity or the other physics properties of the world. The ball, however, I do want it to respond to the world, therefore I attached a rigid body to it. Now let's go ahead and make the ball bouncy. To do that, I need to create a physics material. Not a material, but a physics material. I'm going to call this bouncy stuff. And when I do, if you look over the inspector, it gives me certain fields that I can modify. The bounciness property is a property that goes from 0 to 1. 1 means that the ball will retain all of its energy when it bounces. 0 means it will retain none. If it retains none, that means the ball doesn't bounce at all. I'm going to give it a 0.8 right now. I'm going to go back to my game, and I'm going to drop my ball again. Well, my ball didn't do anything. Why not? Well, I thought it would bounce, but if I look over here in the sphere collider area of the ball, where it has material, I don't have anything. So I better put my physics bouncy material over there, and now let's see what happens. The ball bounces. It doesn't bounce a lot. I found that if I also put the bouncy stuff on the planes collider, I get a better bounce. So that's pretty nice. I can simulate the bounce of a ball using the physics material on both game objects. That's all for now. In the next movie, we'll talk a little bit more about types of collisions and how to detect them.